Okay. So yeah, today we will be going through. Today is the second day of the seminar series. Today we'll be going through micrometer screw gauge. Mm, so as usual, in a practical, we need to know the purpose, material, theory, procedure, some special and some special points. Okay. Uh, okay. What is the purpose of this experiment? Obviously, to learn how to use a micrometer screw gauge and to build precision in measuring thin objects. Why do we use a micrometer screw gauge? Now, we use a micrometer screw gauge only to measure mm, thin objects. Right? We can talk about that later. When we go down, we can talk about that. Anyhow, materials is simple. We need the micrometer screw gauge and the object we are going to measure. Okay. Here in your practical book, we have a thin wire, steel ball, and a microscopic slide, and a photocopy paper. Let's see how we can use, how can we measure photocopy papers, whatever measurement, okay? When it comes to that point. Yeah, that's it for materials. Theory. So our first theory is knowing the parts of a micrometer screw gauge. Now, කට්ටි ඉන්නවානේ. ඔය ඉන්නවා. What is this called? දාන්න බලමු chat එකට. That is called the anvil. Make a second one, spindle. Yes, so we have the anvil and the spindle. Then we have the main scale. We can call this the sleeve. My sleeve. My main scale. This is going to be the circular vernier scale. Circular scale circular vernier scale. Thimble and thimble head. Thimble නම් මේක thimble head කියලා මතක තියාගන්න. Yesterday there was also another story for death bar pin කියලා කියන්න ඕන. ඒ වගේම for thimble head we can call it a ratchet. එහෙම ඒක ඕනේ නැති දෙයක් thimble head මෙයා thimble නම් මෙයා thimble head කියලා මතක තියාගන්න ලේසිනේ. The head of the thimble. That's why we call it the thimble head. So ඒකට marks තියෙනවා. So those are the first parts of the vernier scale. Sorry, vernier scale, micrometer screw gauge. How do you find the least count of this instrument? We least count is same as the last time. The length of a main scale division divided by number of circular scale division. Vernier scale division here we take the number, take it as number of circular scale divisions. Now, normally in a micrometer screw gauge, what is the least count? What is the least count? What is the least count for micrometer screw gauge? Down, chat it down. Yes, 0.01 millimeter. But there are two different forms of vernier caliper scales, okay? First of all, we have a vernier caliper, not vernier caliper, we have a micrometer screw gauge where it has 1 millimeter as main scale division and 100 circular scale divisions. That is one type of micrometer screw gauge. And then there's another one where we have 0.5 millimeter main scale divisions with 50 circular scale division. Which one is more accurate? Both of them are enough and more accurate. Then what will be the difference between these two? Why is these two values different? Why do we have 1 millimeter here and 0.5 millimeter here? In a micrometer screw gauge, what are these values? This value corresponds to another value as well. What is it called? Yes, it is called the pitch of the micrometer screw gauge. Pitch can micrometer screw gauge works in a screw principle. මේම screw එකක් තියෙනවා. මේ screw එකේ between two threads the distance is called the pitch. This pitch can be either 1 millimeter or 0.5 millimeters. Yes, that's it for theory. This is a small lesson because this is a small lesson to learn because you are mainly working this with the knowledge of vernier scale. Okay, next one. Next, we are going through procedures. What is the normal procedure of any instrument? First of all, what should we find first? We have to find the not zero either. We have to find the least count first. Yes, we are finding the least count first. Our first step is to find the least count. First step is finding the least count. Second step is second step is zero error. Finding the zero error. Here, unlike in vernier scale where you can see it is onto the left or right, here here also we have positive and negative zero error, but there's a small difference. How can you say whether it is a positive zero error or not? So basically, first of all, to take a reading, we have to find. So we have the sleeve. In the sleeve we have we are talking about zero error. So we have the main scale right over here, and then here should the vernier scale may zero be below the main scale or above the main scale for it to be positive zero error? මෙතනද is it below the main scale? Yes, it should be below the main scale. So when the vernier scale is zero is below the main scale, you can take the positive zero error by just reading the number of what you call divisions. By finding the division that coincides with the main scale. Then that is the positive zero error. In case of a negative zero error, what happens? Negative zero error, the negative the vernier what do you call the circular scale zero is above the main scale line. Yes, therefore, then how do you find? එතන බලන්න equation එක දාලා තියෙනවා negative zero error will be number of vernier scale divisions minus the reading the number of the division we are getting here. Let's say 48. Okay, 48 minus not minus times the least count. With the number of vernier scale divisions we are putting 50. If it is 50, if the number of circular scale divisions is 50. 100 if the number of circular scale division is 100. Okay, neither. If it is okay, put a thumbs up. Okay. So that is the zero error. Same as previous in the vernier caliper, we are subtracting the zero error from the reading we get. හරි. එතන පොඩි error එකක් තියෙනවා. Okay, there's small mistake in the period. It doesn't matter. You know this is about micrometer screw gauge. Then vernier caliper name it should be micrometer screw gauge. So first of all, how do we measure the micrometer screw gauge? We keep the object in between the anvil and the spindle. Now you should have some idea about you when you look at an object, you know you have an idea about the thickness of that object. Like thickness, let's say 2 millimeters. If the thickness is 2 millimeters, and this spindle and like let's say the reading is at 10 millimeters. At that from that point onwards, we are not using ratchet. Okay. First of all, we are using the thimble to rotate and get it close enough to the plate as possible without touching it. When it is close enough, then only we use the ratchet to spin and what do you call, take the measurement. So we have to spin the ratchet until you hear tick sound. Tick sound. Why do you get a tick sound? The ratchet. What is the purpose of the ratchet? What is the purpose of the ratchet? To prevent overpressing. Yes. To prevent overpressing only, the ratchet is used. So when there's a certain amount of pressure, there are some pins inside. Okay. These pins will start jumping up and down, not allowing the thimble to move. So at that time you hear some tick sound, so you have to stop rotating the ratchet. Then okay, now you have rotated the ratchet. Now you will have reading something like this. Yeah, and then this. Okay, and there will be readings. Okay. First of all, we take the main scale reading. Let's say main scale is 1 millimeters and circular scale has 100 divisions. So first of all, we take the main scale reading. Main scale reading is going to be then 0, 1, 2, 2 millimeters. Okay. And let's say this is 45. This line is 45. Then what we are going to do is we are going to be looking at the circular scale from top to bottom. Okay, so when we are reading, scanning, we have to scan from top to bottom, from here to here, top to bottom, and then figure out the exact line which coincides with the main scale, and then we take that as the circular scale division. Okay, then the reading will be what? Main scale reading plus circular scale division times least count. So here it's going to be 2 millimeters plus 45 times. If there are 100 divisions, what is going to be least count? 1 millimeter divided by 100, 0.01. So we are having 2.45 millimeters here. Okay, Nick? So that's how we take a measurement in a micrometer screw gauge. We are just 20 minutes in. Next. Okay, so we went through we went through the materials, procedure, the theory, and all those stuff. Now we are going to be going through special points. Same as vernier caliper, okay? Same as vernier caliper, what should we do to get accurate measurements? How to prevent random error? We have to take measurements at 3 or 4 distinct locations and find the mean of that value. Yes, we have to find the mean of that value. What does it reduce? It reduces the random error of that experiment. Next thing, just as in vernier caliper, this also will have 0 errors. Okay. Then what could be the cause? Same reason as what do you call? Same reason as vernier caliper. We will be having rust between anvil and spindle. We will be having rust between anvil and spindle. Otherwise, anything කියන්න බලමු. Yes, there will be wear and tear between the anvil and spindle. Okay. Normally, if there is rust, will there be positive, negative, zero error or negative zero error? If there is rust, yes, it will be a positive zero error. If it is wear and tear, negative zero error. Okay. So that's what else? Same as in vernier caliper, to ensure that the instrument is accurate, we have to keep the percentage error below 1%. Okay. So to keep it at 1%, what is the equation of percentage error? It is going to be least count divided by reading times 100% is equals to 1% කියලා දාගන්න උනා. Now reading is equals to 100 times least count is 0.01. So we have 1 millimeter. So in a micrometer screw gauge, we have to take a measurement greater than 1 millimeter in order for it to be accurate. Okay. Now I will ask you a question. Okay. For that question, put the answer in the chat. Okay. Now paper. If we take a photocopy paper, is the photocopy paper 1 millimeter thick? No, yeah, it is only thick around for like 0.15 millimeters or something. So how can we take the measurement of such a paper using a micrometer screw gauge? You can use it. Okay, it can do that. By taking one which we know the count of paper, take reading and divide by number of papers. That is also correct. Take multiple papers. If you have one paper, then what can you do? Then එක paper එකයි තියෙන්නේ. You have one A4 paper. Yes, you can fold it or තව වැඩක්වත් කරන්න පුළුවන් instead of folding it, because if you actually properly see fold කරනකොට අර මේ when you fold a piece of paper, it doesn't fold exactly like this, one over the other. You will get huge waves after the fourth and fifth. Yes, we can cut it into pieces and measure. Okay, fold it එකත් හරි. Folding එකත් හරි. But the only issue we can get using folding it is, if you are folding it more than 4 or 5 times, you will get bends instead of you will get some bends and resistances. Then you can't get the actual reading. Otherwise, same as vernier caliper, you cannot use this micrometer screw gauge to measure. What you call micrometer screw gauge to measure some objects. What are those objects? Objects which can compress. There's another point. I just checked it on Maker. What do you call resource? Well, not resource. Practical handbook. It's just in tiny letters. Not tiny letters. It's just in one line. What is the other one? There's another one. Yes, objects with large rigidity and can. Yes, brittle, thin object like brittle. You can use glass. Glass is a brittle object, but if it is like 3 or 4 millimeters, you can use because that glass won't break. But let's say the glass is 0.5 millimeters. On now, even the pressure that is limited by this instrument is will be also too much for this object. Then it will break into pieces. So we cannot use thin brittle objects. Okay, we can use some brittle. We can use the brittle. We can find the measurement of brittle objects, but if they are thin, you cannot find. Okay, ne? So that's it with the whole practical. That's the explanation for the whole practical. If you have any doubts or anything, I'll give you 5 minutes. Then we'll go to the questions. Do you have any doubts? Let's see, are there any people in YouTube? To calculate positive zero error should be multiply coinciding division and least count. To calculate positive zero error should be multiply coinciding division and least count. Yes. If not, how am I going to get the reading? Positive zero error is a reading. Okay. So we have to find the reading. Then Kyomoko. I don't have any diagram. Yeah, let's just take this. Let's say the zero is here, okay? Zero mark is here. Same least count, 1 millimeter, and yeah, main scale length is 1 millimeter, and there are 100 divisions. Now, may I 45 now? Zero is somewhere here, ne? Zero is somewhere here. So it is a positive zero error. Yes. Just the answer 45, will it be enough to calculate positive zero error? No. We have to, the actual positive zero error is 0.45 millimeters, not 45. So you have to, yes, find the division and multiply it by the least count. Okay. While I clear some doubts, you can do the start with the 1990s paper. I am erasing this part. Uh, Also, and one more thing. In our micrometer screw gauge, we have something like this. What is that used for? What is it called? Memadala. There's a circle and then there's a small handle to it. You can move this left and right. What is this called? Yes, that is also called the locking screw. So what happens when you keep an object? Let's say you keep a piece of glass, and then when if you want to measure it by taking it out of the glass, what will happen? The glass can angle. When it angles, it will the what do you call the reading will slightly change because we are working with 0.01 millimeters, much more smaller than what we can actually measure using our eye or something. So to prevent that, what do we do is we actually take the measurement, use the thimble head, rotate it and press it, yeah, without over pressing it. You get the ticks until you get the ticks and you turn the ratchet. And then after that, you lock the system using the locking screw. And then only you take the, what do you call, yeah, you take the measurement. Because the pitch is, there's another reason as well. We have something called pitch. This is running on threads. So between these two, there's 1 millimeter gap. Okay. If it is held by this part, if the weight is held by this part, with a small jolt, it can move up by around like 0.2 millimeters. Therefore, we have to lock the instrument and then take the measurement. Okay then. I'll erase the board. Let's go with the 1990 A-level paper. Figure shows a section of the micrometer screw gauge, or um, shall I discuss or shall I give you time to write? If you want time to write, raise your hands. Kite, they kite. 3, 4, 5. If you don't want time and you want me to explain right now, put a thumbs up. Thumbs up, Nani. I'll give you 10 minutes, okay? I'll give you 10 minutes. Let's see how things goes. Okay, shows section of a micrometer screw gauge. It is not control scale. It has 50 divisions. Timber screen and then rotated one completed. Most of the. Okay then. Let's start discussing the paper. There's not that much questions, what do you call, things in that. First question. What is the least count of the instrument? Obviously, 0.5 millimeters is divided into least count is equals to 0.5 millimeters divided by 50, which is equals to 0.01 millimeters. Okay. When taking a measurement, the component marked A, the ratchet, serves an important function. What is it? Is it A, B, first one. What is it? Prevent overpressing of the instrument, overpressing of the object, or we can write to take measurements without damaging the object. To take measurements without damaging the object. That also we can write. Prevents overpressing is also correct. That is also another answer. How do you make sure that the ratchet has been utilized correctly in performing the functions mentioned in B1? To turn the ratchet until you hear tick sound and stop moving until you hear the tick sound. The ratchet spins without the spinner moving. How do you make sure that the ratchet has been utilized correctly? Yes, that is also correct. How do you make sure that the ratchet has been utilized correctly? Yeah. By when the ratchet spins, you can hear the tick sound. By that, we can say that the ratchet has been utilized correctly. Next thing, how do you determine the zero error, if any, of the screw gauge? How do you determine the zero error? We bring the anvil and spindle to be in contact using the ratchet and then find the reading or zero error of the micrometer screw gauge. How do you determine the zero error? We have to bring the anvil and the spinner in contact using the ratchet and then find the reading of the measurement. This will be zero error. The screw gauge is used to measure the diameter of a steel ball, and the reading obtained is shown in the diagram above. Okay, so what is the diameter of the ball? Make that okay. We have 0. What are these and what are these? These caps will be moving as 1, 2, and 1, 2, 3 millimeter. This will be moving as 0.5, 1.5, 2.5 millimeters. So you should know that on the top you will have, yes, we will have 1 reading such as 1, 2, 3, 4. Below we have 0.5, 1.5, 2.5, 3.5. Okay, then we have the zero scale and this says 15. So 2.5 plus this is going to be 0.15. 2.5 plus 0.15 will be 2.65. Yes, the two answers you gave are correct. For measuring the diameter of a thin wire, a micrometer screw gauge is more suitable than a vernier caliper. Give the reason for it. It's a short answer. Very, very short answer. Yes, the least count is smaller in the micrometer screw gauge. Otherwise, there's another one. It's unnecessary. If you write that answer, you'll get all marks. The another thing is fractional error is high in when we use a vernier caliper. Okay. Better write smaller least count as well. Yes. Percentage error is higher. Not less percentage. What are they for measuring diameter thin wire? Yes. Yeah. Micrometer screw gauge have less percentage error. A lower percentage error. Um, if using a micrometer screw gauge, how do you obtain a better value for diameter of sonometer wire? By taking measurements at several places and finding the mean of that value. We can find the better value for diameter of a sonometer wire. Name two other measurements which could be performed with vernier caliper but not with a micrometer screw gauge. Name two other measurements. Internal diameter, yes, and then depth, yes. We can, yes, internal diameter and depth. That is correct. Anitaya Yonder or others can also answer. Now, shall we do the 2004 question as well? First question is they are asking for parts. Let's just see, may yeah. Can you please type it on the chat and may put it in the chat? What are the parts? A, B, C, D. A, B, C, D. Just write it one after the other. All the students. Main scale. Let's see a few more answers. Okay, sleeve. Yes. First two answers are wrong. It's not the main scale. We are talking about sleeve. Why is it the sleeve? Why can't we just say main scale? Because they haven't, the arrow is not pointed towards the main scale. It is pointed towards the side. So it is going to be the sleeve. What else? I දාන්න ඉතින් කෙනෙක් දැම්ම කියලා අනිත් අය නිකන් ඉන්න එපා. කොහොමද දාන්නේ? From now on, I am banning the word ratchet. ආව එකනේ දාන්න බලමු. ratchet එපා. එහෙම එපා. The next person who is writing the all four answers, don't write ratchet. Niminanta bhai. Is everyone sleeping? Put a heart reaction if everyone is here without sleeping. ඉන්නවා. Very good. Okay, very good. Next. What is the least count of the above micrometer screw gauge in millimeters? What is the least count of the above micrometer screw gauge in millimeters? Yes, 0.01 millimeters. That is good. Write down the scale reading for the diameter of the bore shown in figure 1. 6.48 හරිද? 6.48 ඒක හරි. වෙන කවුරු ඉන්නවද? 6.48. Figure 2 shows a situation where it's talking about zero error. What is the zero error? No, what is the zero error? Yes, zero error is minus 0.03. Yes. Then what is the correct answer? Correct answer is 6.51. Okay, that is fine. Fourth one. Write down the fractional error of the measurement. Yeah. Fractional error is 6.51 divided by 0. No. 0.01 divided by 6.51. That is correct. What is the precaution taken in the micrometer screw gauge to avoid overpressing the object? We um, we use the ratchet to yeah, we use the ratchet to spin until we hear tick sounds. And also there's another point, okay? Make it කියන්න point it doesn't actually matter. How many tick sounds should you hear before you stop? How many tick sounds should you hear before you stop? No, not one. එහෙම දෙයක් තියෙනවා. We don't have it in our AMLs, but yes, you should hear three tick sounds. We should go through three tick sounds. ඒ පළවෙනි tick sound එක ආවා කියලා එයා මේ ඒ pressure එකට ආවා කියලා කියන්න බෑ. But let's say we go to second notes බෑ. Third එක තමයි හරියට මේ හරියන්නේ. Fourth එක වැඩි. So after three tick sounds we have to stop. ඒක අහලා නැහැ. ඒක කවදාවත් අහලම නැහැ. මේක ලියන්නෙත් නැහැ. හරිද? We just right when we hear tick sounds we have to stop the measurement. Hari. Now C part 1. You are given with a meter ruler, spirometer, vernier caliper. What do we so to find L what do we need? To find L we are using a meter ruler. D1 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 වලට micrometer screw gauge නෙමෙයි. D1 diameter vernier caliper. Yes. D2 my D2 D2 is going to be Kandy we have enough and more time. D2 vernier caliper. Yes, D2 vernier caliper. Okay, that is also fine. T is simple name micrometer screw gauge. You have only 3 millimeters there. There's nothing else you can find. Yes. What experimental procedure would you follow to obtain a better value for the thickness of the disc? Simply take the measurement at few different places and find the mean value. The thickness of a certain type of polythene sheet is smaller than the least count of the micrometer screw gauge. Propose a method. Propose a method to find the thickness of a polythene sheet. If you wanna, we can finish early. See, to find the thickness of a polythene sheet, what do we do? Measure a stack of sheet and divide by the number of sheet. මේ paper එකේ ඒ උත්තරේ තිබුණේ නැහැ. මං හිතන්නේ. Because we are talking about sheets, okay? This sheet could be yes, fold the sheet into several times is the correct answer because yes, we can keep like 10 or 20 sheets and find the measurement. But the sheet can be either the size of a small phone or it can be the size of the whiteboard. If it's the size of the whiteboard, can you fold the sheets? No, neither. So it is better to fold the sheets and then take the measurement. Also, when you fold the sheets, how do you count? For first fold, it will be 2 sheets. For second fold, it should be 4 sheets. For the third, Third fold, it will be 8 sheets. So basically, the number of sheets will be equals to 2 times me power the number of folds. And then we will get the number of folds in those sheets. Okay, neither. So that's it for today. If you have any doubts, no, did you understand everything? Put a thumbs up if you understood everything. Yes. Okay then. So thank you for everyone to joining. Let's wind up the session. If you have any doubts, please put it in the chat.